Whew. It's been a rough setup today. Computer's just not playing. The Linux machine ran the game fine, but just like had a spaz about trying to record audio. But here we are. And now we got this webcams looking like terrible, but we will push on. We get, what do we got? Half an hour before the lecture starts for 229, where we'll be talking about concurrency. So this is a little, what is it? It's an intro to concurrency, I suppose. What I find most interesting about stuff like this is that this is another view on the same thing I already know how to do. Right? I know how to do concurrency. You don't know how to do concurrency, probably, maybe. But I still learn heaps from seeing other views on concurrency. Other views on things I already know how to do is perhaps one of my most valuable experiences. I really love that. And this one in particular, I think, is a great view on concurrency because of the way it kind of, I mean, it's totally different to any other way you'd learn it as a programmer. But it is a programming game. These guys, what are they called? Tomorrow Corporation. They also did Human Resource Machine, which is a game where you learn assembly programming. But again, in a completely different way to how you would normally learn assembly programming. It's somewhat hidden. I guess it's not really that hidden. It's pretty obvious what you're learning. And they don't pretend you're not learning programming. But I'm going to try and talk about, as we go through this, the bits that transfer to normal programming and how that relates to normal programming, because that can be tricky to see, I think. So fingers crossed the stream's working all right. I'm running it off my laptop. It's the first time I've done that. And none of the settings have quite worked out the way I wanted them to. So we got this running in a window in the top left because the stream appears to only be... Anyway, I think we got it working out okay. Let us play some games instead of just chatting about stuff. So I've already been playing this game. I'm not going to pretend I haven't. I got 30 years in, so I do have some idea what's going on. There are a few levels that I got stuck on for a little while where you won't have to watch me get stuck, which I understand is not the way. Ooh, I get to pick a picture of myself. What am I going to look like? Well, I shouldn't look like me. I should look like some kind of every person. Let's go this person. That's me. Green hair. Oh, hey. Yes, it does. Just like me. Okay. All right. This game, same as Human Resource Machine, it pretends you're in a building going from floor to floor. So it's got little cutscenes. They don't go too long, which is good. I won't have to cut them out to make this watchable. And I've got my tea, of course, to drink while the cutscenes are on. I don't quite know how to get the volume sorted, but hopefully they're at a reasonable level. The setup here is that, what is it? Humanity's built machines to replace them, and now they don't know what to do. Well, when I bought it, it came with a soundtrack, and I was like, why am I going to be? I'm not interested in the soundtrack of a computer game. But actually, while I'm playing it, I'm like, hey, that's cool. I might put that on my rotation. Simple graphical style, but they do a really good job with it. This is the longest cutscene. Come on, come on. We want to do concurrency. I could close it. Yes, let's close it. Let's move on. You can watch the rest of the cutscene yourself. So the setup is humans have nothing to do. Now let's give them something to do. And I'm the person who's writing the instructions for the workers. So this person here's talking to me. I'm late. Yes, of course. Everyone's already here. They're just humans standing around waiting for something to do. So it's a flip, right? Because in fact, when we program computers, and here we're programming humans. But the humans do exactly what I tell them to do. So they're really just computers. Here I've got to get each one to go and pick up the green data cube. And it's showing me the 3 different instructions I have. These instructions, in the human resource machine, it was the assembly machine instructions. Well, same thing here. They're also machine instructions here, but it's at a higher level machine that we're operating on. This machine only knows how to do 3 things: step, pick up, and drop. But once we drop them in here, we'll see that there's some things we can do with the step. We can tell it which direction to step in. And I think of these as functions with input parameters, right? And the input parameter here is which direction I want you to step in. So there's one step function, but that with 9 different directions, 8 different directions, that gives me 8 different variants of that one. Now, some I definitely want them just to step forward. Now when I drop the pickup instruction in, that's got no parameters. That's a 0 parameter function. It can only do the one thing, just pick up whatever I'm in front of, and then I've been told just to drop it again. So we've got the controls for running the machine here. I can step it one at a time. I can control the speed they're running at, but generally on a simple level, I'll just play it. There's one thing I really like about this game, and I'll try and show it to you again in a later level, but I just got the glimpse of it there. Level done, easy. So that was a tutorial. They're basically tutorials at this point, but interesting ones because we're learning new things. All right, these guys have to move the data cubes somewhere. Move the entire line of data cubes down by 2 tiles. Just set it right there between the nice potted plants. Okay, so there's nothing magical here. I'm just going to step forward 1, pick it up, step forward 2, step forward, and step forward. Now, because I've only got the same 3 instructions, I don't really have any choice in how I do this. I love the way it shows me the individuals doing their steps, which step they're up to along the way. And brilliantly, every one of these people looks different. They don't need a name, they don't need an ID. They've got a picture for themselves. I think that's a really cool trick they've done there. I guess it's not a trick, but this is something that comes up in programming, right? If this is a model of concurrency, which it is, we're imagining 1, 2, 3, 4, 5, 6, 7 different programs all running at once. Well, how do I identify this program apart from this one, from this one, from this one? For a lot of the programming, I don't have to. I just run them. They all get the same program. But there are times where I have to identify one from the other, especially when I'm debugging. And how do I do that? Well, often I'll get a number assigned to them, or I have to make variables for them. But here they've all got a personal identity. All right, this guy wants everyone to throw their data cubes into the holes. So each one has their own hole, and I'm allowed to exit the room through the hole. So that makes it simple, right? Ooh, jump. Okay, so this time not jump in the air. This is the jump. It's in an assembly language version of jump. You'll be used to using control statements like loops and ifs, but at the bottom level, your program only uses jumps. And you can construct an if from a jump, and you can construct a loop from a jump. Here we're constructing loops from jumps because we want to do the same thing over and over again. I want to step. Do I need to step to pick it up? I don't think I do. I think I can just pick it up straight away. No, I've got to step to the right to pick it up first. So we'll do that. Then I'll be over the data cube so I can pick it up. Then I want to step again to the right, but I don't just want to do it once. After I've done that once, I want to go and do it again. So now I've got a program for every one of these little guys. They're all going to run that program over and over. And the one program is correct for all of them. That's the key thing I want us to get at this point, is that the one program is running for each person and has to be appropriate for each person. And here that's very easy because all of them are just going to keep walking to the right until they jump off the hole, jump into the hole. Again, I can see the people where they're at in the program, and they jump off. Here's an ocean. Here's an autumn forest. Yes, very mindful. Oh boy, I need some food. I haven't eaten yet today. That's why I only got half an hour I got the timing wrong today. I had 11 o'clock in my head instead of 10 o'clock, so 10:30 stream today. An important decision. Can you guess what's coming? It's an if statement. Okay. Because if our little workers have to do something different from the other little workers, how can we possibly know which worker does what? Well, we can use an if statement because every program can inspect something about its environment and then do something different based on it. And that's how we get the workers doing different things even though they're running the same program. And every worker runs the exact same program but will have to do a different thing. For example, the top guy has to move left, next one has to move right, then left, then right. So I need some kind of external stimulus to tell these people which direction they want to be going. And the if statement here will have parameters to help me with that. So the if has conditions, we'll have conditions to help me with that. So the conditions in this if statement are a position, let's say, and then an equality just like we're used to, and then it can be equal to one of these things. These are like the values in this language, in this programming language. A value, like a variable could have the value something, nothing, a number, a data cube, a worker, a hole, or a wall. So those are the things we can check against. But we can also check against what exists at another direction, I think. Just direction equals direction. I haven't tried that. I wonder what that'll do. But in this case, I need the external stimulus to tell the little worker which way to go. So I could use the holes to tell them which way to go. I don't want you to go in the direction of the hole. But because each worker is in a different location relative to the hole, that's not a good stimulus. There's one that's perfect for all of them, which is where is the data cube in relation to you. So if to the left of you is a data cube, then you best be stepping left. And otherwise, you best be stepping right. So standard if statement here. This is why this isn't an assembly language machine like a human resource machine was. This is a higher level language. More like Java would be. So, but it doesn't have loops. It only has jumps for us when we want to do loops. So I guess it's a middle road. If the left of us is a data cube, then step left, otherwise step right. That's it. That's all. But then I've got to pick up the data cube. So no matter who you are, you then have to pick up a data cube. And then I've got to make you do this over and over again. Okay. So you've got to keep stepping left if you originally stepped left, and you've got to keep stepping right if you originally stepped right. I need to make a little loop, but it can't be the same loop for everyone. So maybe if below you was, if next, so the trouble I'm having here is I've lost my condition to tell me whether I'm stepping left or right. I can't look left or right to see if I had a cube. And this is a good example, I think, of one of the troubles with concurrency, because all the little workers have to work in this environment. They only have what they can see around them to decide which of the workers they are. I've gotten the wrong approach here, so I'm going to reset and think about this. Once I've picked up the cube, I'm going to keep moving. You're welcome to give me suggestions, by the way, if anyone can see the answer and I just can't get my head around it. That's fine. I'm not used to trying to do thinking in front of a screen while I'm watching 12 things. So I definitely want these guys just to like keep stepping, but they've got to pick up before they step again. I mean, I guess I could do this, right? If I just make it step left, pick up something, step left, pick up something, step left, pick up something. I know that'll work because probably picking up does nothing if there's nothing there. Step right, pick up something. Step right, pick up something. So if I run that just to see, so they all move and then they say, I don't have nothing to pick up, and then they just keep going, and that's all very fine. But I'd like to do better. That kind of, I've got nothing to pick up, feels like a warning or an error or something I'm not doing right. I don't think the lady at the end is going to care. So it didn't come up on her important decision. Like I said, I got a tick for it, but I feel like I can do better. But let's just go back and... So it shows me the program again, yeah. So I use the if to decide whether I was one of the guys going left or one of the guys going right. And here we can see we've kind of got two programs jammed together. We've got the program for the guys going left, we've got the program for the guys going right. But because the same program gets given to... there was a condition for a hole. The same program gets sent to every worker. All the programs must be there with the ifs between them to help them work out which one they are. Yeah, there was a condition for a hole, but because my worker's not right next to a hole right now, like the holes are above and below, but that's the same for both of them. The real question is, how do I keep... The question I really got is, how do I keep stepping once I've picked it up? So I can see it now. If I just change this to, when you're in that one, then please step left, pick it up, then immediately step left and just keep stepping left. That's perfect. And then over on this one, I want to step left, sorry, step right, pick up, and then once I'm in there, just keep stepping right. So now there's only one pickup for each program. It involves more instructions, but it's more correct. I mean, there is no, the only correct here is pleasing the woman on the end, but I'm a programmer, so asking my little dudes to pick up something when there's nothing in front of them felt incredibly wrong. There we go. Now they go to their doom without complaining. Okay, so you can see the jump is being used for a loop and a loop only. We can actually use jumps for ifs, and if you do human resource machine, you'll learn how to use jumps for ifs. Alright, next level. There's a whole bunch to this game, and I'll probably keep streaming various levels that I think are interesting. Not free to download, no, this one's $16 or something. But it's a game, it's fun. It's available everywhere, almost. So this is, it's got Linux binaries and Windows binaries, the whole lot. You can just play it anyway, it's nice. Yes, you are learning programming. In fact, I'm already solved this assignment. Okay, so this guy is going to solve the work. Is supposed to pick up that cube down below, but there's a bit of a maze to go through. So I've got to fix this guy's program. So I'm debugging his program. And look, they've slowed it down where the problem is, and the worker walks off into the hole. Okay, it's no good. We can see another feature. Yes, before I edit step. Okay, stepping, and I can see where that person is. It's got their little head next to the step they're at. It's the kind of thing we can't do when we're writing compilers and debuggers, but it's such a lovely way to see program execution. So then we go past the jump, we step right, we're now in a loop. So the loop is saying it's a loop, so the jump is going to cause it to loop, but it's only going to loop if the thing next to me is equal to nothing, as in a blank cell. So I'm just going to keep going right while there's a blank cell. And then eventually I get to a point where there's not a blank cell, and I do my last step, which is the step down. That's no good. So the condition I really wanted was not that the thing to the right of me was nothing. I wanted the condition that the thing to below me was nothing, because then I could step down into the nothingness. So there's the bug, I can see it already. I want to step down. If this thing down is not equal to a hole, what I think I could also do is equal to a nothing. I think that'll both work in this program, but you can imagine programs where you'd have to do the other one. So let's do that if the down is nothing, because nothing doesn't mean a hole. Nothing means an empty square that I can actually step on. So Oh, so no, I don't want the, so that should be not equal to nothing. If the thing below me is not equal to nothing, then jump back around so I can step right again. Keep doing that. And then when that's finally finished, steps down 3 times and pick up. I think that's right. There's only one worker in this program, by the way, so they're just trying to teach us a bit more about using the if condition before we move on to doing it with multiple people, I suppose. Let's see. Multiple people. This place is a mess. The engineers left data all over the floor. We want to organize them in a nice line, the bottom row. So you'll notice here I've been using phrases like what's our external stimulus to help us work something out, an if statement. The levels are built that way. You can see that the last row, the place it wants me to put the data, has something that delineates it, the hole right underneath. So I can know when I'm at that last slot because I'll see a hole. So I definitely just want to step forward a number of times. How many times? Well, I want to step forward as many times until I get to the data cube. So we'll put an if the cell I'm on has a data cube, sorry, it does not have a data cube, then please jump back and just step down again. Otherwise, so I could put this in the else branch, or I can just put it below because both those two things mean the same. Pick up whatever I'm on. Now I'm moving down again. Step down, but this time I want to step down until I get to the last row. So I'll do the same trick with the if and the jump, where I say if the cell below me is not equal to a hole, i.e. I'm still somewhere on the board, then jump back up there and keep stepping. And when I'm finished with that, let's actually do the drop. So notice here we actually have multiple programs going on here. We've got the program for step 1, pick up the cube. We've got the program for step 12 times pick up the cube. But it feels more like one program than the earlier one did, where we had it broken, split into halves, because the programs are more related to each other. But again, it's the if statements that are helping the programs to do different things, even though they're all running the same program. So there are parts of the code they skip over that the other people don't skip over. And we see this very quickly now they've branched, right? The various programs, which are all running the same program, were in different parts of the program at different times during it was running. All right, you guys have a lecture to get to, so I'm going to call it quits there. And I'll let you know when the next one of these comes up, because I think it's worth going through at least the interesting levels in this game. There's a lot more interesting ones, and maybe going through all of them. There's a ton of levels. So that was the thing for today. Make sure we're thinking one program running in multiple places, somehow all having to cooperate with each other and deal with whatever the environment is around them. See you next time.